Hello and welcome to today's webinar, co-sponsored by Competitive Carriers Association and Award Solutions. I'm Lucy Hoda, Senior Vice President of Media and Communications for CCA. We're glad to have you with us to learn more about why 5G spectrum matters. I'll give just a very brief introduction before turning it over to Mark, our presenter and the 5G spectrum expert. Okay, next slide. Just a little bit about CCA. We represent nearly 100 competitive carriers located throughout the U.S., many of which you see here, and about 150 associate members who are the vendors and suppliers that sell goods and services to the carriers. Next slide. CCA's priority is advocacy work on behalf of the carriers, but our mission also includes providing networking and educational opportunities for our members, which includes things like today's webinar with Award Solutions, who is also a CCA member. Next slide. We have a ton of educational opportunities and networking events coming up at CCA's 2019 annual convention in September. We're going to be in Providence, Rhode Island, and I encourage you to check out the program at ccaconvention.org to see the great things we have lined up for the show. I would like to mention that early bird rates end on August 9th, which is coming up really soon, so register early to save. Next slide. Award Solutions is going to be at the show, leading a couple of sessions on Tuesday, September 17th, and they're free to all registered attendees. The sessions were extremely popular at our spring event, and we're delighted that Award Solutions is going to be back with us this fall, so I encourage you all to check them out. Next slide. CCA and Award Solutions also have partnered to provide a 5G certification program, and CCA members receive discounts on the course. We've heard a number of good things from people that have completed the classes and said it's fantastic. So I highly encourage you to look into the next program, which began on August 5th. And Mark can tell you a little bit more about the program as well. So I think now is a good time, Mark, to turn it over to you for the presentation.
Great. Thank you so much, Lucy. I appreciate that. It's always a pleasure working with CCA and partnering with you guys. So thank you for this opportunity, and I'm looking forward to this webinar, as well as seeing a lot of my CCA friends and others at the CCA conference coming up. And so we're looking forward to the presentations there, as well as this 5G ready knowledge certification program. And this will kick off in August. So if you like what you're hearing today and you want to learn more, please jump into that program, which will open up in August. So thank you. Today we have quite a varied audience, and I'm excited about that. We are going to cover the topic on here's why 5G spectrum matters. A couple of quick notes. If you have not yet done so, please make sure that in WebEx you have opened up your participants panel and your chat panel. So please go ahead and do that now. That should be relatively straightforward to do. You should see a toolbar on your screen to be able to open up participants and chat. If you have that open, and if you don't mind, give me a quick green check or just a check mark from the chat, or you can say yes or something like that. So I just put that in mine. You should be able to see that at the bottom right. I see a hand up from Syed. Thank you, Syed. So great. So please go ahead and do that. I see some yeses in the chat window. Fantastic. Please use the chat window for questions. I love questions. It's a little small. I'm going to be squinting to see it all. Great. I see some other hands. Fantastic. If I say something funny and you want to put a smiley face, please do that. If you want to put a clapping hands because you like something, that's great. And if you have a question, please put it in the chat. Make sure that you send it to all panelists. I have my colleague here, Bill Stringer, and he'll be answering some of the chat as well. Hello from France, it looks like. So I know there's people from all over the world, and I'm excited about this session. So let's dive in here. And actually, before I do, two other quick points that I'd like to make, and that is the fact that we have a PDF reference guide that contains most of the key slides, and we will make that available to everybody next week. And we will also make available a recorded version of this webinar. So don't worry about the slides. You'll get all the key slides next week with the PDF reference guide. Again, use the chat window for questions. One thing I will say is, since we have a varied audience, we have some technical folks and some non-technical folks. I want the technical folks to bear with me initially. I've got about 10 minutes where I lay the foundation on spectrum. Some of you that are RF engineers are likely already know that topic quite well. But hopefully it'll give us some common vocabulary, and hopefully it'll equip you to be able to explain this to others in a simpler way. And then for the non-technical folks, when the technical people are asking some questions, I'll do my very best to answer them in as simple terms as possible. But with the varied audience, we'll go back and forth on some of the deep stuff as well as some of the higher level things. So welcome. It's really my privilege to be able to be here and lead you in this. Use the chat for questions. Let's dive right in. I don't know if I said this, but my name is Mark Arms. So in this course, we'll start with some spectrum fundamentals, wavelength, propagation, penetration, licensed versus unlicensed, and how we achieve duplexing. We'll look at some pros and cons of different bands. We're also going to look at some of the bands that we use for LTE, and all of those bands are available for us to use for 5G. We'll understand what the third generation partnership project, or 3GPP, means when they talk about frequency range 1 and frequency range 2 for 5G. We'll also discuss the key tier 1 operators' millimeter wave spectrum holdings, and we'll look at who they what they have and what they're deploying. And then we'll look a little bit at the end about 5G subcarrier sizes and the implications of that to latency. So I just want to throw that topic in here at the end. So hopefully, like I said, WebEx, start your chat window, ask questions, start your panelist or participants window, and comment there. All right, fantastic. Let's get going. What is spectrum? Well, spectrum is electromagnetic waves, and basically these electromagnetic waves are all around us every day, all day, being used for a variety of different things. In fact, we're using them right now. You and I are using them right now to be able to see. So there is a part of the electromagnetic wave spectrum that is visible. Most of the electromagnetic wave spectrum is invisible, like ultraviolet, X-ray, or gamma. Those, notice, are higher waves. And you notice that as you go higher, that means the waves are actually shorter. I'll talk more about that in a minute. And then there's other lower waves, infrared, microwave, and radio. And as notice, lower waves means that they oscillate less frequently, and therefore they are longer waves. So with radio waves, we've been able to do a lot over the last decades, really, if not more. We've been able to use radio waves to transmit radio, normal AM, FM, TV, satellite, Wi-Fi, and cellular. So these radio waves are what we use for communications and are able to transmit information across these radio waves. So how do we measure radio waves? We do that with a unit of measurement called a hertz. And a hertz is how many times in 1 second does the wave cycle. Go from bottom to top, back to bottom, if you will, or top to bottom, back to top. And if it cycles once in a second, that's 1 hertz. If it cycles 1,000 times in 1 second, that's a kilohertz. And by the way, you and I know kilohertz because 820 kilohertz, for example, is an 820 AM radio station here in Dallas. I think that's WBAP, but I'm not sure. 1080 is another one, for example, that you may heard of. If the wave oscillates 1,000,000 times per second, that's called a megahertz. And again, we know about megahertz because that's where a lot of cellular spectrum has been utilized for our cellular systems. For example, 700 megahertz spectrum, where a lot of 4G LTE has been deployed. And then if the wave cycles 1,000,000,000 times a second, that's a gigahertz. And we know those because of 1900 megahertz, for example, the PCS band, or 1.9 gigahertz. Notice that 1,000 megahertz is 1 gigahertz, and we can translate those that way. So this is important, fundamental of how we're measuring, or the unit of measurement we use for spectrum. Let's talk about some properties of radio spectrum. Fundamentally, there's 2 properties that I want to highlight. Property number 1 is that the lower the wave, the longer it is, and therefore it propagates further. The shorter the wave, or the higher the wave, the shorter it is, and it propagates less. Think of dropping a big rock in a pond, creates big waves, and those big waves can be seen further away. If you drop a small rock in a pond, it creates shorter waves, and those waves are not seen further away. So lower waves, or lower frequencies, which are longer waves, they propagate further than higher frequencies, which are shorter waves, which propagate less. A second key point is a penetration. But actually, before I get there, propagation, back to that, you've experienced this when you're farther away from the city. You may be able to receive the AM channel, but you may not be able to receive the FM channel. Why? Because that AM channel is on a lower frequency, which has longer waves, which propagates further. And this is important for all cellular systems. This is true today for 4G LTE, whether you're using mid-band or low band, and it's going to be especially true for 5G when we add millimeter wave bands to the low and mid-band deployments. So the second is penetration. And by penetration, I mean, can the wave penetrate walls, cars, billboards, other things like that? How well can it penetrate through obstacles? And one of the ways you can see this and have experienced this is when a car pulls up next to you and they have their radio blaring, what do you typically hear first? Let's see if anyone can give me a quick answer on the chat on what do you hear first when a car pulls up and they've got their radio playing. All right, I see a comment, on amplitude or energy. I won't quite get that. I'll talk about that in a minute, maybe. Lower hertz, the bass, there we go. Why do you hear the bass? Well, because it's all about the bass, as we all know. Actually, the reason we hear the bass is because since it's a lower frequency, it penetrates out of that car and into your car better than the higher frequencies of the voices or the cymbals or other things like that that are more unique. And this has an effect on cellular systems as well. How well do you get reception deep in a building or deep in a parking garage? Well, it depends. If that operator that you are with has low band frequency that they've deployed, you will get better reception. If the operator you're with has high band frequency that they've deployed, then you may not get as good a reception. Why? Because that high band frequency, which is shorter, doesn't penetrate those walls as well as the low band frequency, which is longer. So this has a significant implication for operators. If you consider operator one with a low band frequency that they're using and they deploy, they would cover this space potentially with one tower, while someone else who has a mid-band frequency, in other words, slightly higher than this lower band, they may need 3 towers to cover that same area. So fundamentally, if I'm an operator deploying a system in a rural area especially, and I need to cover a large geographic area, that low band frequency really enables me to have a lower capital expenditure or CapEx because I need less towers than the operator that's deploying using a higher band frequency. Maybe it's a bit mid-band frequency, et cetera. They're going to need more towers or basically more radios. Now, there's good news though for that operator. The good news for the operator on the right is that they have 3 sets of equipment here, towers, radios, etc. They are using the spectrum over 3 different times. So they're repeatedly using that. So that gives them 3 times more capacity. So notice that having these towers does give you a unique advantage in that now you have more capacity. So in this picture, the operator on the right, using the higher frequency, has triple the capacity of the operator on the left. Why? Because they're reusing that spectrum 3 times. The operator on the left can do the same and create 3 towers and radios and do the same thing with that lower band spectrum. But if they deployed for coverage, if they both deployed for coverage, then the operator on the right would have more capacity because they're reusing that spectrum 3 more times than the operator on the left. So I just want to highlight the pros and cons of that low band spectrum versus higher band spectrum. All right. And this is true, obviously, for 5G as well as for 4G LTE. So for 5G, all spectrum bands are useful. Every spectrum band is useful. Every spectrum band has its different advantages. I want to use low band spectrum for longer propagation and better building penetration. I want to use mid-band spectrum so that I can have higher density and therefore maybe some higher capacity. And I want to use millimeter wave because it gives me much larger channels and therefore allows me to have higher throughput. So that's very important. We're going to use all bands in 5G. So let's talk about some of these ways that we can use this. One is unlicensed spectrum. And unlicensed spectrum is spectrum that is free for anyone to use, like the spectrum we use with our Wi-Fi router. The problem with unlicensed spectrum is that it's uncoordinated. Anyone can use it. So for example, if I'm in my home and I have my Wi-Fi router, I may get some interference from my neighbor's Wi-Fi router. If I am in a rural area and have a Wi-Fi router, I may not get any interference. If I'm in a city and I'm in an apartment complex and I have all these neighbors around me, I may get a lot of interference. So just be aware that unlicensed spectrum is fantastic, and we are using it today in 4G LTE with features like license assisted access, and we will be using it in 5G. By the way, the release 15 from third generation partnership project, or 3GPP, does not include unlicensed spectrum, but release 16 from 3GPP, which will be frozen at the end of this year in December, does include unlicensed spectrum. So we expect 5G networks to leverage unlicensed spectrum next year, probably towards the latter part of next year. So what do we talk about the most, though, when it comes to spectrum and cellular systems? That's licensed spectrum. And in order to get a licensed spectrum here in the US, the FCC gives you exclusive rights to use that spectrum. And therefore, it has minimal, if no, interference. Actually, I like to ask this question. The largest interferer, if you have licensed spectrum, is more than likely you. So your other towers, your other users, et cetera, are the largest form of interference in most cases when you're using licensed spectrum. So clearly this is spectrum that we can count on. It is licensed for the operator's exclusive use, and they can use it as they need to. How do they acquire it? Well, in every country, there is a body that oversees that. And here in the US, that's the FCC. And what they do here in the US nowadays is auctions. Before, they did some things that we would call beauty contest. Operators would say, here's what I plan to do. The FCC would say, hey, I like your plan the best. I'm going to let you use this spectrum. But nowadays, it's primarily through auctions, and they make a particular block or several blocks in a band available, and people can sign up prior to participate in the auction. Once they've signed up and the auction begins, they start bidding. And when the auction is over is when no one bids on any block for any license for any region. So these auctions, you don't know how long they're going to go. Sometimes there's a big momentum and then it tapers off. Other times you see this ebb and flow. But fundamentally, the highest bidder for that block, for that specific region, wins that license. And now that bidder can use that license as they need to and as they want to deploy a cellular spectrum, including a 5G network. All right. I wanted to get some of those basics in so that those that are less technical can follow. Please feel free to jump in, by the way, in the chat window and ask questions. I know Bill looks like he's already answering some. So hopefully you're seeing some of those answers. Thank you for the questions, but please keep them coming. One last thing I want to talk about before I introduce a quick poll is if you didn't win that spectrum at auction, can you acquire it post-auction? And the answer is obviously yes. There's two different ways. You can lease that spectrum from a license holder. You can buy that spectrum from another license holder. You can even swap spectrum with other license holders. In fact, that happens quite frequently where people won different blocks, and after the auction, the blocks that they won that aren't as useful as they thought may be useful to another operator, and that operator may have some blocks that are useful for that operator, so they may swap. So I see a question from Michael on his chat window. Michael, if you go through the toolbar, you'll see the WebEx toolbar, and one of the little bubbles there says chat. You can click on that, and that should get you up and going. I see another question from Ken. Yes, Ken, spectrum is specific to a region. So what I mean by that is when you win a spectrum license, you win it for that particular block and that particular geographic region. And I'm going to explain that a little further in just 1 second. All right, another way to acquire licensed spectrum is to just buy a company that has already won that spectrum. And when we think about 5G deployments, this has happened quite a bit. In fact, there were companies like Fiber Tower, Straight Path, XO, and First Communications, all of which owned millimeter wave spectrum, and all of which have either been bought or have sold that millimeter wave spectrum to tier one operators here in the US. So we see this happening all the time. I have a question here from Naveen, I think it is. What are the frequency ranges of free and licensed? I'm going to answer that in a minute. Can we share radio spectrum and launch the network with, yes, Shadam, I think that is. I'm having a hard time reading the questions here, but yes, there are options to share spectrum. One operator can decide to share their radio access network and its associated spectrum with multiple other operators. Millimeter wave spectrum is not free spectrum. And that definitely depends on each country. But here in the US, it is not free. Like I just said, people have bought companies and or bought millimeter wave spectrum from previous owners. And people are participated in the auctions, which I'll get to in just a minute. All right, before we move any further, I have a question for you to kind of set up this next slide. And then we're going to look at the bands in LTE and millimeter wave and go from there. So you should see a poll that is coming up. And I want you to jump in there and answer that poll on duplexing. Poll open. All right. Jump on in there. Good. I see some people beginning to answer. Fantastic. While you're answering that poll, if you finish early, feel free to give me a quick question. Looks like the time limit is for 5 minutes. I'm probably not going to leave the poll open for that entire time. Just running through the questions here. Thank you, Brian, for your comment about it being all about the base. Ken, I think I answered your questions as well as Naveed. All right. I'm going to give you just a little bit more time. It looks like most people have begun answering or are almost complete. I'm going to give you about 30 seconds more before I close that poll. Fernando, I see your question in here. What is the current usage of frequency bands that are intended to be useful? That'll come up. I'll address that in just a minute. Someone looks like they cannot see the poll. You may have to scroll up to the WebEx bar and click on polling. Otherwise, it should have come up on your right automatically. Okay, Robert, great question by Robert Kelly. Is there any recurring charges for spectrum? So Robert, typically the way the FCC does it, and this is not true for every auction, but this is true for many these days, is you get that license. Remember, that license is for a block for a specific region, and you get that license for roughly 10 years. It varies. Every auction varies, but they have a year period. Within that period that you have that license, the FCC expects you to deploy some sort of service, and they have different steps along the way. You better deploy a service that reaches 30% of the geographic area that you have a license for. Then you better have a service in 3 years, let's say, and then 50% in 5, 80% in 8. I don't know, right? Something like that. And then after that, if you continue to meet those requirements, you simply reapply and this 10-year license is renewed and you get it for another 10 years. So as long as you're meeting the FCC requirements for the spectrum that you won, there is no additional charge for continuing to keep that spectrum. Again, every band and everything is treated a little differently. The requirements are different. The length of the license is different. However, you get the idea there. So great question, Ken. It is an interesting question when you think about some companies that have bought spectrum that have not developed anything yet. And those companies that have not bought anything yet or developed anything yet really have sometimes are under the gun. So for example, Dish has some spectrum that they haven't developed, and now they are deploying an NB-IoT network in order to meet some of those requirements so they can continue to keep that spectrum. And now, especially with the Sprint and T-Mobile merger, things continue to change there. But you see how important that is. All right. Sounds good. I'm going to close the poll real quick. And you can, it's closing in 15 seconds. So if you haven't had a chance to do that, jump in. You have about 5 seconds to finish the poll. All right, and I'm going to share with you the poll results. All right, you should see the poll results now. So you should see, do you see those, Bill? It looks like duplexing technique that's defined by the FCC for most. This is not completely accurate for all of them, but for most of the low band is frequency division duplexing. Fantastic. A few of you answered orthogonal access duplexing. A few of you answered time, and a few of you answered code. But the correct answer is frequency division duplexing. And which midband spectrum uses time division duplexing? It looks like a third of you got the right answer. It's that 2.5 and 2.6 gigahertz. So fantastic. That's the right answer. Let's cover that material real quick on duplexing, just so that we're clear, and I'll refer to it again in a minute. So in duplexing, which is the objective here, is how do I have my uplink communication from the mobile to the tower not interfere with the downlink communication from the tower to the mobile? Well, I can do that in a couple of ways. One is frequency division duplexing, and another name for that is paired bands. And in that case, I have a channel for downlink communication. Let me see if I can write that a little cleaner. And then I have another channel for uplink communication. So therefore, I have a paired band, two different channels. In TDD, however, I only have one channel, and I separate my uplink and my downlink with time slots. That's why it's called time division. So today, most LTE networks are deployed using FDD here in the US. LTE networks deploy TDD as well. It happens around the world and even here in the US. But just primarily, most people think about here in the US as deploying FDD. But like we said, the 2.5 and 2.6 gigahertz band, the band that Sprint owns and operates, does have LTE and TDD. This is not a technology war. The FCC or every governing body in every country decides what spectrum they're going to make FDD and TDD. And there are some pros and cons to each, but overall, both work just fine. The reason I want to mention this is if you're used to talking about your FDD deployment in terms of channel sizes, and you say, I'm using a 10 megahertz channel, or I'm using 10 megahertz channels, remember the total here is 20, because you're using one for the uplink and one for the downlink. However, in TDD, you may say, I'm using a 20 megahertz channel. So if you're comparing, I'm using 10 megahertz channels in FDD to someone saying I'm using 20 megahertz channels in TDD, they're actually saying roughly they're using the same amount of spectrum. So just be aware of that. So 10 megahertz channels in FDD means that you have two for a total of 20. A 20 megahertz channel in TDD means you have one channel for 20. So those two are the same. All right, enough on that. Let me keep moving here. So let's look at the LTE bands that are available here in the US. Traditionally, these have been called low band spectrum. You see that some bands, they all have ranges. Some bands have names. Some bands have names that aren't very popular. So I've just included some of the popular names, but not all of them. I see a question here from Josh. Do FDD channels have to be symmetrical, or can you have, okay, great question, Josh. What I'd like you to think about, Josh, is for the most part, I want you to think of FDD channels being symmetrical. That is 99% of the time. There is something these days called a supplemental uplink or a supplemental downlink channel, and those can just be unidirectional, but those are exceptions to the rule. So what I want you to think about when you hear FDD is that those are both symmetrical and not asymmetrical. So great question, Josh. Thanks for that question. Again, this is a decision that the FCC makes, not a decision that an operator potentially makes. Now, the operator can petition the FCC or the governing body in that, but they don't have to. What is a symmetrical channel? Question from, I can't read your name there. No problem. It just means that if you have a 10 megahertz channel on the downlink, you have a 10 megahertz channel on the uplink when you're deploying FDD. Their sizes are symmetrical. And that was Josh's question. Can they be asymmetrical? Can I have a 20 megahertz down and a 20 megahertz up? And the answer is, for the most part, no, but there are some exceptions. All right, let me continue here. So these are the popular low band channels. In addition, we have what used to be called mid-band, but now, this was just mid-band, and then these were called high band. But now with millimeter wave, all of these now are called mid-band. And in fact, technically, the mid-band channels go all the way up to 6 gigahertz. So every one of these channels, by the way, has a band number. And if you look at certain phones and their capabilities, or if you're working with a network manufacturer and you want to know what spectrum bands their radio is working at. They need to know specifics. This is way too generic. So they need to know specifically what band you are using, or what channel you are going to, band number you're using. So all of these have band numbers. So you can look at a phone's technical spec and see what they're using, and they'll give you specific band numbers there. And I'm just highlighting some of the more common band numbers here for you. And again, this chart will be part of the PDF reference guide that you'll get at next week. And as well, the recorded webinar will be available next week as well. Okay, so these are some of the more common ones. I do want to mention that of these, they are primarily FDD. There are some TDD bands here and there, but they are primarily FDD. And the major TDD band here in the US is the 2.5 and 2.6 gigahertz band that Sprint owns. A lot of. They don't own all of it, but nearly all of it. The other band that obviously is gaining a lot of momentum is the 3.5 gigahertz band, or the CBRS, Citizens Broadband Radio Service. This band is band 48, and you're starting to see phones that are now supporting band 48. So you're starting to see that in the more recent phones. Okay, I see a couple of other questions here. I'm going to get to yours. I can't see the name, Mary something. What happens to spectrum that is not bought? That's a great question. And I believe that what happens to spectrum that is not bought is the FCC continues to maintain it, and they may add it to an auction later. So for example, the 28 gigahertz auction ended recently, and not all of the licenses were bought. Why not? Well, there might have been one that covered a very small rural area that no one has coverage for. And so that license isn't bought. The FCC just holds it. All right, and I am going to get to your questions. CBRS license, good question from Josh. So CBRS has a very unique approach, Josh, and it's a shared spectrum. And we have, by the way, a 4-hour tech primer on CBRS. I encourage you to go to our website at awardsolutions.com and check out when the next one is available for you. But CBRS is using shared licenses. So with that, that means that they call them generally available access, and that means anyone can access those at any time within policies, and as long as they're directed and under control of certain devices or managers that manage that dynamically. So it is going to be generally available, which means anyone can access it. There's also some priority access license, which means that would be more licensed. So it's a shared band that has 3 types of users: incumbents, priority access licenses, and general availability. It's the first time that the FCC is doing this. It's very unique. And you can learn more, by the way. Let me just show you this real quick. You can learn more about that at the CBRS Alliance website. And you should see that now on my screen. It's cbrsalliance.org. And we expect the CBRS Alliance, and they've branded it OnGo. We expect CBRS to be available for usage any day now. All the testing is complete. We're just waiting on the official go ahead. Once that happens, you're going to begin to see people use CBRS in LTE. We won't see people use CBRS in 5G quite yet, primarily because unlicensed spectrum is not in the first phase 1 of 5G, release 15. It's in phase 2 of 5G, or release 16. All right, great. Thanks for that question, Josh. Let me jump back here. So I've gone ahead and listed, someone was asking about the unlicensed band. I've gone ahead and listed the 2.4 gigahertz and the 5 gigahertz bands here, so you can see where those 2 unlicensed bands are. And primarily they're used for Wi-Fi, but they're used for a ton of other things: garage door openers, baby monitors, all kinds of things like that, where you want people to be able to access that. All right, let me keep us going. Let me remind you that all spectrum is available for 5G, and all spectrum has good use for 5G, or 5G has good use for all spectrum. So we have all of the spectrum we just talked about, and that spectrum is called frequency range 1, or FR1. And that is what you'll see in the 3rd generation partnership project, or 3GPP specs. So these are historically called sub-6. The spec actually goes up to about 7 gigahertz and below is all a frequency range 1. Frequency range 2, say that 3 times, or FR2, begins at 24 gigahertz and goes all the way up, even up to 100 gigahertz. So that's FR2. So you're going to see some things in different releases that talk about both. I see a question on Wi-Fi 6. Thank you for that question. Wi-Fi version 6 will use both the 2.4 gigahertz band and the 5 gigahertz band. Will shared licenses become also available outside of the US? Joel, that's a good question. We don't know yet. It depends. What's unique about Spectrum is it's a natural resource, and therefore it's under the control of that government. So every country will decide, do we want to do something similar to what the FCC has done with CBRS and use this shared approach where we have incumbents, priority, and general availability access licenses, or not? And that's TBD. Different countries take different approaches, and we'll see how that pans out. Okay, so the main point I want to leave you with on this slide is that all spectrum is good spectrum for 5G, but there are some pros and cons to each. So I've talked about the FR1 already, and I've already given you those band numbers in LTE. Let's just talk about FR2 for a second, otherwise known as a millimeter wave. There are four different bands that are currently defined in the third generation partnership project specifications. And so I want to highlight those. First is the 28 gigahertz band. And that band is the band that some tier one operators have already some of that spectrum through their purchases of Straight Path or XO or others, right? Fiber Tower, First Communications, and several other companies. And then the leftover, I shouldn't say leftover, the remainder part of the 28 gigahertz band that was available, the FCC auctioned that off this year, or it started last year, and the results were made known in May. And I'll talk more about that in a minute. So this is one of the bands in millimeter wave. Another band in millimeter wave is the 24 gigahertz band. No one owned the licenses for that until this latest auction, auction 102. And then there's the 27 or 28 gigahertz band that's mainly defined for international. Notice there is some overlap here. So these band numbers become very important because if you're developing a radio, you need to develop a radio for a very specific thing, and I'll give you those in just a minute. And then finally, the 39 gigahertz millimeter wave spectrum is also defined in the specs, but to date, the auction for it has not happened. However, once again, there are some operators that have previously bought other companies and or acquired some of this spectrum over the last few years. So we'll talk about each one of those in just 1 minute. So what are the band numbers here? Well, you have N258 for that 24 gigahertz, and you have N261 for the 28 gigahertz, and then N260 for the 39 gigahertz. I think I saw some questions about that, and I hope that answered those. Let's see here, has 3GPP defined a band for 24 gigahertz? So it just answered that. How about the use of 3739? Absolutely. 39 is what I'm summarizing this band as 39. Notice it goes from 37 to 40. And notice that here in the US, to my knowledge, no one has any 37 gigahertz. I'm not positive on that. But that auction, along with the 39 gigahertz auction, along with the 47 gigahertz auction, will all start December of 2019. Okay, is TV UHF frequency licensed? Yes, it is. If I want to transmit radio in a particular city, I have to have license. If I want to transmit a TV channel in the city, I have to have license. Someone said roaming will be a real nightmare. It can be. Roaming already is a nightmare, but believe it or not, phones support huge amounts of bands. In fact, let me just show you one real quick, just to give you an idea of that, so you can kind of see that real clear. That's not what I wanted to show. Here we go. All right, I hope you can see that right now with the LG V40 ThinQ. This is the phone that was released last year. Notice I'm using a website called GSM Arena. You can use it. I like it because this network piece usually says expand. You'll have to click on expand, and then it shows you all the bands. And notice in parentheses is the range, but then you see the number. So if you're using that SMR or 850 band, then your phone better support band 5. If you want to use the new AWS3, that's band 66. It also includes AWS1, by the way. If you want to use the new band 600, that's the band that T-Mobile is using a lot of. you can see it has band number 71. And just for comparison, oops. Just for comparison, you see that the LG V50 ThinQ, it's 5G capable. It has a very similar range of LTE bands, but it also has the range of 5G bands, and it says millimeter wave, but in the GSM Arena site, for one reason or another, it doesn't tell you the band numbers. You'll have to do some further digging, and if you're Googling that, I would suggest you say something like band number, and then you should be able to find that it supports band numbers that we just shared here. For example, I'll give you another one, the Samsung Galaxy S10 5G. For Sprint, it supports band 41. And for everyone, it supports band N261 and N260, which are the 2 millimeter wave bands that are currently being used here in the US. All right, will future smartphones devices support all frequencies? The obviously overgeneralized answer is yes. However, you have to be very careful depending on the operator that you are, the frequency that you own. You have to be very careful that that phone will work on your network. So that's something that you have to check. But as you just saw, phones support a long list of bands already. What is a typical cell size? Okay, we'll talk about that in just a minute. Okay, let me keep us going here. Let's review some of the auction results and talk about a couple of details there. And then I do want to hopefully leave some time at the end for Q&A. So I'm going to hurry up a little bit here. In the 28 gigahertz auction, it was auction 101. They were auctioning off 2 blocks. Each block was 425 megahertz wide. Those are huge blocks. Compare that to the larger blocks in 4G LTE, previous low band and mid band, which were as large as 20 megahertz. That was about it. There were some exceptions to that. The 2.5 and 2.6 range that Sprint owned or owns is huge comparatively. They own about 140, 160, 180 megahertz there. But these are 2 425 megahertz blocks. That's very big. The other thing I want to highlight is that they use county licenses. And this is an advantage for CCA members specifically because it means that these licenses were smaller. So if I'm a CCA member, my coverage area is smaller. I don't want to buy a license for a larger area than I intend to cover. I want to buy a license that fits and meets my needs. If I'm a nationwide carrier, I would prefer larger licenses because that means I need to win less licenses in order to provide nationwide coverage. So there's always this battle on what size license should we leverage. And notice there was about 3,000 licenses and it brought in approximately $702 million. By the way, it was a very small percent of the total band. Roughly a quarter of the band was being auctioned. Why? Because roughly the other 3/4 of the band was already owned by AT&T and Verizon and a little bit by T-Mobile as well. So that's why only a quarter was auctioned. That's why only 702 million was raised as compared to the 24 gigahertz band where all the band was auctioned. And notice it's 7 100 megahertz blocks. So roughly the same size, 850 megahertz in one versus 700 megahertz in the other. And they use partial economic areas. You see the number of licenses, and it raised a little over $2 billion. I've added in here some of the top winners and the number of licenses that they won. This slide will be available to you in the PDF reference guide. In addition to that, I will also share links in the PDF reference guide where you can get the 28 gigahertz band auction results. As you can see here, I have not listed all the auction winners because I just didn't have room to do that, but you can see here all of the different auction winners in auction 28, over 28 gigahertz, auction 101, and then auction 102 for 24 gigahertz. AT&T, a big winner at over 900 million, almost $1 billion. And then T-Mobile, another big winner that you can see here at, where is it? Here, next page. Come on. There we go. T-Mobile at 800 million. All right, looks like we got some other questions. What is partial economic area? Great question, Amir. So let me, I should give you some money because you've set me up for my next slide. So let me just talk about that and remind you, you're winning a license for a particular block in a specific geographic region. So depending on how the FCC here in the US defines that auction, it defines how big that region is. And they have several things that they use. Here's a map from the FCC on their partial economic area boundaries. And there's roughly 400 licenses that cover the entire US. And another one is called cell market areas, and those are smaller than partial economic areas. And if you want an entire US coverage, you need about 800 licenses. And then finally, you have county maps. And county maps, we have roughly 3,000 counties in the US. And this is what the 28 gigahertz auction was using, the county licenses size, while the 24 gigahertz auction 102, was using the PEA, or partial economic area boundaries. All these are available on the FCC. They'll all be in my PDF reference guide, links to that, so you can learn more about that. All right, in the US, 24 gigahertz different than spectrum range N258. I just want to remind you, here is the bands. Oops, one more. Here are the bands that are defined. N258 is the 24 gigahertz band, and so that is not different. I'm not sure. Will it be usable in the US, or will we need it? No, it is usable in the US. That auction has occurred, John. So we can talk offline here in a minute if you need more info on that. Okay. Let me wrap up with a couple of points here, and then I'll open it up for some Q&A. First, I just want to say that here's the ownership. These are not, granular. So this is a big view. If you think about what Verizon owns, they own a very large chunk. In fact, somewhere in the 65% of the 28 gigahertz band here in the US, they own that. And they own a good sized chunk in the 39 gigahertz band. T-Mobile, on the other hand, really got a large chunk in the 24 gigahertz band. They had previously owned some in the 28 gigahertz, won a few more in the auction, and they previously owned licenses in the 39 gigahertz. We'll see what happens when that auction occurs later this year, scheduled for December. AT&T largely stayed out of 28 gigahertz. I think they won just a few licenses. They're more focused on the 24 gigahertz. We just saw that, as well as the 39 gigahertz. They're an incumbent owner on there. So notice that that's the case. I just see a great note here that Steve Berry, actually, with the CCA, was part of the advocacy for these partial economic areas, which were much smaller than the cell market areas, so that it could benefit CCA carriers. So it's a very important point, right? CCA carriers prefer these smaller licenses because they're more likely to match their intended coverage area rather than larger licenses, because then they have this large license when they only intend to cover this area, and they have to spend more money. It costs a whole lot more money. So that's always a struggle between the smaller carriers and the larger carriers. And there's some compromise that we're finding. Some of the other ones here that I think are surprising: US Cellular was very active in 24 and 28 gigahertz auction, and they own good chunks there. Windstream is the third or fourth most active in these auctions as well. And then Starry as well in the 24 gigahertz. So this is my view. Again, this is not exact by any stretch of the imagination, but I'm trying to give you a feel for the millimeter wave auction results and the ownership of that millimeter wave spectrum. What's the outlook on timing for potential 26 gigahertz auction? I don't know the answer to that, Thomas. That has not been added here in the US. That band is primarily an international band, and the only additional bands that we know about here in the US are that 39, 37, and 47, and that auction will start in December. Okay. A couple of other key concepts here. Antenna size is proportional to wavelength. If you have a lower band wavelength, that wavelength is longer, and therefore your antenna size has to be longer. If you have a high band wavelength, that wavelength is shorter, and therefore your antenna size can be shorter, like dramatically shorter. We're talking about a few millimeters here, and that means if you use a half dipole antenna element, your antenna element can be half the length of that wave. So very, very small. And what does that do? That enables you to use multiple antennas. And one of the techniques that's important to note is called MIMO, multiple input, multiple output. And I can use these multiple antennas in a couple of different ways. I can send different information off of two different antennas so that as a receiver, if one has some interference problems, hopefully the other one does not, and you can mix and match and combine what I sent. But the other powerful way is sending separate streams of data down multiple antennas, therefore doubling, quadrupling, or whatever my throughput. And so that is MIMO. That's available today in LTE. We talk about 2x2 MIMO, more recently 4x4 MIMO, in some cases 8x8 MIMO. However, in the millimeter wave band, we can do something that we call massive MIMO. Because these antenna elements are so small, I can do 64 antennas. I can do 1024 antennas. Again, depending on the spectrum I'm using, whether that's high in the mid-band or all the way up in the millimeter wave. So with massive MIMO, I have an opportunity to do something called beamforming. And with beamforming, I'm basically taking the energy of these and aggregating them and focusing my energy so that I can get a beam that I can direct to a particular area, or even a beam that I can direct to a particular user. It's a bit like the high beams on the car. If you use your normal lights, that energy is spread, but you can certainly see what's in front of you. But when you use the high beams, that energy is focused, and therefore it can be focused on further ahead, and you can see things earlier as you're on the highway or whatever going faster. So beamforming is a technique that we do not take advantage of in the low band spectrum. We can begin to take advantage of in the mid band spectrum, but we can really rock and roll with it in the millimeter wave or high band spectrum. And that's really impressive and very important in distinguishing that spectrum. So let me summarize some of the implications on the spectrum, and then I've just got a couple more charts to finish, and then we'll have some Q&A. If I deploy 5G in the low band, because of the historical allocations of 5G, of a low band spectrum, my carrier sizes, and by carrier, I mean my RF channel, not a wireless carrier. I call them wireless operators. My carrier size or wireless channel or RF channel is smaller. However, my coverage size is relatively large because that low band spectrum propagates well. If I deploy 5G in a mid band spectrum, I can have larger carrier sizes potentially, depending on how much I own. Because there's more of it, there's a better opportunity for me to own more. For example, Sprint in that 2.5, 2.6 gigahertz range. However, my coverage area will be more medium coverage area. Finally, in the high band or millimeter wave or 24 gigahertz and above, we have hundreds of megahertz of spectrum available. So now here I can have huge channel sizes, huge carrier sizes, like 100 megahertz wide, 200 megahertz wide, 400 megahertz wide. And if you think about it, a 400 megahertz wide channel here is up to 20 times larger than a 20 megahertz channel here. It's a massive difference. This is the big attraction of millimeter wave. What does that larger channel mean for me? It means I have significantly higher capacity, higher throughput, and I can provide much, much higher peak speeds. However, my propagation is much lower. So it's high band for spectrum. The frequency is smaller, so it's going to propagate a lot less. We're talking thousands of feet, right? 3, 4, 5, depending on environment. It's more line of sight. It's more affected by buildings, billboards, etc. It doesn't penetrate well. So it has some negatives, but it has some huge positives. All right, the other thing I want to mention is the antenna size. On the low band, it's large, medium, and then small antennas in the high band. What does that mean? It means I can do limited beamforming here in the medium, but I can really rock and roll with beamforming in the high band range. So notice I get much, much higher throughput, peak speeds, and capacity, much, much lower coverage. So that means I need many, many more antennas or radios to deploy. But I can use beamforming to help overcome some of the propagational issues. So this slide will be part of the PDF reference guide so you can digest that a little bit better. One nitty-gritty thing that people often want to talk about is how does that affect latency? And if you see here, if I deploy 5G and I have my subcarrier sizes at the normal 15 kilohertz, you're going to hear technical people talk about subcarrier spacing. but I want you, when they say that, to just think about the size of my subcarrier. That's what we use today in 4G LTE, 15 kilohertz spacing. Notice how long my time is, but if I want to half my time, what I can do is double my subcarrier sizes. So I can double them to 30 kilohertz. And that is something that we can do in low and mid-band spectrum. But the beauty is we can double it again to 60 in mid-band spectrum. We can double it again to 120 kilohertz sizes in millimeter wave spectrum, and therefore provide dramatically less latency in the millimeter wave. One key advantage that exists there. So if I summarize this up, I would say that when it comes to your 5G deployment, you have to think about what spectrum do I have and what am I going to use? Low, mid, or high band spectrum. Once I've decided that, that's going to affect my channel bandwidth or my carrier size. Do I have a 5 megahertz low band? Do I have maybe 40 megahertz in the mid band? Or do I have 200 or 400 megahertz in the millimeter wave? Once I've decided that, I can decide on my subcarrier spacing. The larger the subcarriers, that means that my transmission interval is going to be lower and my latency will be lower. So that has an immediate impact on the slot duration, which impacts the latency. And then finally, all of that's going to impact my throughput. So if I have the larger bands in millimeter wave, much higher throughput. If I have the lower bands, which are smaller, then I'm going to have less throughput. All right, so let me end there. I hope that was helpful for you. I hope I didn't go too fast in some cases. I see several questions, and I've got a couple of minutes. So let me start answering some of these. Why are we calling out the international band? I was just calling that out because it's in the 3GPP spec. Steve Berry is wondering about the C band, and the C band is a band that is gaining momentum on discussion. It's in the 3.7 to 4.2 range. Satellite companies own it. There's a big brouhaha about whether they can auction it off themselves with the FCC help and keep the money. That seems a bit questionable. We'll see how all that plays out. I don't understand all of the implications there, but I expect that that band will at some point in the next few years be available. Why was the millimeter wave auction for 425? Yeah, that's a great question, Michael. I don't understand all the reasons the FCC does that. My only guess, and it could be wrong, is adding some guard band, but that may not be accurate. Another question, can we use 4G and 5G in the same spectrum? The answer to that question is yes, and I don't have time to talk about that technique, but I can do some sharing in a static way. But there's also something called DSS, dynamic spectrum sharing, where I can share spectrum dynamically. So the quick answer to that is yes, but come back to another session that we have at Award Solutions on 5G on the RAN, Radio Access Network. We talk about some of these things. On 5G spacing, dynamic, no, typically the spacing is not dynamic, Brian. Thank you for a couple that said it was excellent. Someone's having to go. How much end users are ready to pay for 5G? That's a good question. We don't know how much end users are willing to pay for 5G. We'll find that out over these next few years. Now, I want to remind you that this is just an insight into what we do here at Award Solutions. Remember, the CCA show is coming up, conference is coming up. Please attend that. And also, don't forget to sign up for the Foundations in 5G certification program that we offer. And Bill has sent a link to that in the chat, so you should see that link. Please join us for that. That kicks off in August 5th. Come say hi in Rhode Island at the CCA show. Feel free to hang out here for a little while. I'll answer some more chat questions as we go along. I do want to open up one more poll, if you don't mind, before you drop off, and just go ahead and give us some feedback on the presentation. I sure would appreciate it. It's just a few questions, so if you would jump in there and answer those questions, I sure would like it. So it is straight up noon once again here in Central Time. Thank you so much. Thank you for jumping into the chat. I hope this has been super useful. Next week, you'll get the copy of the PDF reference guide and the video. If you have any questions, feel free to email me. My name is Mark Harms, and you can email me at mharms@awardsolutions.com. Thank you all. I'm going to stick around. We'll keep the feed going. And if you have questions, please jump in on the chat. I would love to answer more questions. Thank you and have a great afternoon, evening, morning, depending on where you are in the US. Thanks and bye-bye.